All right, 2.4, zeros of polynomial functions. A couple main theorems that we're going to be using and utilizing throughout the section. One of them is the rational zero theorem. First, we have the basic polynomial function. That's a sub 0. Sorry, ran out of space. And we have a degree greater than or equal to 1. Integer coefficients, meaning the numbers in front of the x's are all integers, and a sub 0 is not 0, meaning this number right here is not 0, then every rational zero of f is of the form p over q, where p and q have no common factor other than 1. P is an integer factor of constant term a sub 0, and q is an integer factor of leading coefficient a sub n. What does that mean? So what we are going to do is we can have an easier time finding out what your rational zeros are if you take the factors of your leading coefficient and the factors of your constant up front and divide all of them. Okay, those are going to be all of your possible rational zeros. And then we're going to use a test where I didn't have this part written down, but this is what we're going to be doing over and over again. You're going to take all the rational zeros, or possible rational zeros, and plug it into the function. Your goal being if your output 0, then it's a 0. It is a rational 0. Here's two examples right here. So let's do this problem on the left here. So, what's your leading coefficient? 1. What are your factors of 1? 1 and negative 1. Your leading coefficient factors go in the denominator. Now, we have negative 30 here. Factors of negative 30. Plus or minus 30 and 1. Then plus or minus 2 and plus or minus 15. Plus or minus 10 and plus or minus 3. And we have also, I ran out of space in between here. We also have plus or minus 5 and plus or minus 6. That's all of them. Divide all of them by plus or minus 1, and our possible rational zeros are plus or minus 30, plus or minus 15, plus or minus 10, plus or minus 6, plus or minus 5, plus or minus 3, plus or minus 2, plus or minus 1. Now what you're going to do, we have how many? 2, 4, 6, 8, 10, 12, 14, 16. All 16 numbers here, you're plugging them into this function, and by your factor theorem, you're looking for a 0, okay? If you plug all 16 numbers in and any of them equals 0, that number is a 0 of this function, okay? Now, there's 16 of them. That will take a long time, right? Use your table function on your calculator and make your life a little easier. So put this function in and then go to your table function and plug in these 16 lovely numbers, okay? That will save you a lot of time and energy. Once you plug them in, you got two zeros, rational zeros, I should say, and that's 2 and negative 5. Now, you might be asking or wondering, like, hey, there's a highest power is 4, and we have two zeros. What's your other two zeros at? One, we're going to be able to look for that later in class, or later in this video, rather. And two, so here are some of the possibilities. There could be imaginary zeros. These could be zeros with a multiplicity of more than 1. So both those are possibilities. Let's do this other one together. So factors of 36, plus or minus 36, plus or minus 18, plus or minus 12, plus or minus 9, plus or minus 6. So we don't need to write 6 twice. We got plus or minus 4, plus or minus 3, plus or minus 2, plus or minus 1. And then we have plus or minus 2, plus or minus 1. Divide them all out. So, Divide each of these terms to get all of our possibles. So we're going to get plus or minus 30, plus or minus 18, plus or minus 12, plus or minus 9, plus or minus 6, plus or minus 4, plus or minus 3, plus or minus 2, plus or minus 1. So I did all of them divided by 1 first. I'll divide by 2, then get plus or minus 18. I don't know why I put 30 here. 36. That was not good by me. Then I don't need to put 18 twice. And then we got 12 divided by 2 is 6. We already have 6. 9 divided by 2 is going to be 9 halves. We do need to put that in. 6 divided by 2 is 3. We already have that. 4 divided by 2 is 2. We already have that. 3 divided by 2 is what we don't have. 2 divided by 2 we don't have. We already have. And 1 divided by 2 is what we don't have. So once again, plug all these numbers into your calculator. There's a lot of them. Okay, so please use the table function to save us time. Yeah. Only one of them works, and that's 2. It's the only 0. Or rational 0, I should say. Here we got the fundamental theorem of algebra. This is a pretty straightforward one. A polynomial function of degree n, where n is greater than 0, has at least one 0, real or imaginary, in the complex number system, and has exactly n zeros, including repeated zeros, in the complex number system. What that means is, where the highest power is, that's how many zeros you're going to have. Okay? Some of them may be repeating, some of them may be imaginary, but that's how many we will be looking for when we do these problems. And then we have the linear factorization theorem, or conjugate root theorem. Linear factorization theorem is pretty much we can write a polynomial that has linear factors. That's what we're going to be doing a lot of in these upcoming problems. Conjugate root theorem is about imaginary numbers. If we have a plus bi as a 0, we also have a minus bi as a 0. Same thing goes for radical numbers. So if I have 1 plus root 2, we also have 1 minus root 2 as a 0. Okay? They always come in pairs. Okay? So if I give you 1, you also should know the other. In this case, I gave you the zeros. Write the polynomial function. Now, there could be multiple answers, but if you were to write other answers than the one I'm giving you, you're making life more difficult than what it needs to be. Okay? So I have a 0 of negative 3, so my linear factor is x plus 3. 1 multiplicity of 2 is going to be x minus 1 times x minus 1. Then we have a 0 of 4i. So we have x minus 4i and x plus 4i. And a little tip for these, always FOIL out the i's together. Your conjugates together, FOIL out. So it's going to get us x squared minus 4ix plus 4ix. I didn't finish that one. And negative 16i squared. I squared is equal to negative 1 if you remember from your Algebra 2 days. And then negative 1 times negative 16 is just 16. So x squared plus 16. And then let's start foiling and distributing. We got x squared plus 2x minus 3 for your first pair. And then we got to distribute the x and the negative 1, get x cubed plus 2x squared minus 3x minus x squared minus 2x plus 3. Let's combine like terms, and we're going to get x cubed plus x squared minus 5x plus 3. And finally, the x squared and 16 distribute out. You're going to get x to the 5th plus x to the 4th minus 5x cubed plus 3x squared. plus 16x cubed plus 16x squared minus 80x plus 48, like terms, and that's going to get you x to the fifth plus x to the fourth. The cubes match up, so we get 11x cubed. And then the squareds match up, so it'll be 19x squared minus 80x plus 48. All right, this is a longer one, so let's find all the zeros. First, let's find all the possible rationals, and then we're going to factor out, okay? We'll show you how we're going to do that. So list all the possibles of 120 over 1, 120, 60, 40, 30, 20, minus 10. Oh, I forgot about 12. And we got plus or minus 15 I forgot about. And 8. And then we got 6 and 4 and 3 and 2 and 1. Okay, now divide out evenly by 1. Plug those in. What do you get? 5 and negative 6 both work for zeros. Okay, so what you're going to do is we're going to factor out the two zeros and using synthetic division. 1, 1, negative 26, 4, negative 120. I need a little more space than that. Bring down the 1. 5, 6, 30. Bring down the 4. 4 times 5 is 20. Add it, you get 24. 24 times 5 is 120. Add it, you get 0. Good thing we got 0 there, or else it's not really a factor. Next we do negative 6. 1, 6, 4, 24. Bring down the 1. Negative 6. Add it, you get 0. 0 times negative 6 is 0. Add it, you get 4. 4 times negative 6 is negative 24. Add it, you get 0. So what are you left with? X squared plus 4. This is not, we can't reduce this quadratic anymore, so we leave like that. So it'll be x plus 6, because we have a 0 negative 6, and a 0 of 5, and x minus 5. And if we were doing the linear factors part, like it said, your factors of x squared plus a number will be x plus 2i and x minus 2i. If you have trouble seeing that, what I would recommend you do is set x squared plus 4 equal to 0 and isolate x. That should help you out. Okay, if you are in regular pre-calc, can't stop. If you are in honors, keep watching. So I'm giving you one of the zeros. In this case, we 1 minus root 6, and we need to find all the complex zeros. So you have one of them. There's 3 more because we see it's a power of 4. So we 1 minus root 6 in our box, and then leading coefficients 1, negative 8, 26, negative 8, negative 95. Little tip, as I say always, we should have a 0 right there, or we did something wrong. So bring the 1 straight down. 1 times 1 minus root 6 is 1 minus root 6. Add it, you're going to get negative 7 minus root 6. Foil that. I'm going to go down below here a little, or off to the side rather, and foil that. That'll be negative 7. 7 root 6 and then minus root 6 plus 6. It's going to be negative 1 minus 8 root 6. Oh, I'm sorry, plus 6. Look, my 1 minus look like a plus. Plus 6 root 7. So I'll bring that down here. Negative 1 plus 6 root 7. Add, get 25 plus 6 root 7. FOIL it. Go to the side here. Get negative 25. Oh, positive 25 actually. Minus 25 root 6. Just realized my mistake. It should be root 6, not root 7. And then that's going to get us plus 6 root 6. And then minus 36. Like terms get us negative 11 minus 19 root 6. Adding, you get negative 19 minus 19 root 6. Once again, FOIL. I'm going to go to the right side here. That's going to get us negative 19 minus 19 root 6. Plus 19 root 6. And then 6 times 19 is 6 times 19, 114. These cancel, nice. 114 plus negative 19 is, well, 95. It worked out, nice. We did 1. Remember our conjugate root theorem. If 1 minus root 6 is a 0, then 1 plus root 6 is also a 0. 1 plus root 6. So bring down what we have here. We should have a polynomial function left over after this, okay? Bring down the 1. 1 times itself is just 1 plus root 6. Add it. You're going to get negative 6, so that's nice. Negative 6 times that term is going to be negative 6 minus 6 root 6. Ooh, that cancels again. We're on a roll here. 19. You get 19 plus 19 root 6. That's going to get a 0. And I don't include our remainder. How silly of me. So what's our polynomial there? We got x squared minus 6x plus 19. We're going to have to use quadratic formula. So it's going to be 6 plus or minus square root of negative 6 squared minus minus 4 times 1 times 19. 2 times 1. 6 plus or minus 36 minus 4 times 19 will get us 76. 6 plus or minus root negative 40 over 2. Simplify 6 plus 2 root 10I over 2, and then simplifies 3 plus or minus root 10I. Now let's write it as linear factors. So it's going to get us x minus 3 minus root 10I, x minus 3 plus root 10I, x minus 1 plus root 6, and x minus 1 minus root 6. That's the linear factorization. Thank you for watching, and we'll see you in class.